Yesterday we talked about permutations and how we can use it to arrange objects. We also talked about how to handle repeated objects, and we also talked about how to use that fundamental counting principle. Today we're going to continue with section 10.1 and look some more at permutations, but we're also going to look at something different called a combination. So let's start with a combination. A combination is a selection of n objects from a group of r objects in which order is not important. And that's the most important thing here. That's really how you know the difference between the permutation and the combination. Remember, a permutation was putting things into an order, so that means the order was important. In a combination, it's not important. An example of this would be I have 8 markers that I can choose from. I'm going to use 4 for my project. I need to choose 4 out of the 8. It doesn't matter which order I choose which colors in. I'm just going to choose 4 different colors. Okay, now here's a bit of new notation, and we're going to look at this the same way in the permutations as well. This notation with this little n, the capital C, normal size, and the lowercase r, the n and the r are little subscripts down there. That is the notation that you will see for a combination. Now, on a graphing calculator, you need to go to the math menu. Okay, there should be a button on there that says math. And you want to go at the top, arrow over until you get to PRB. It's going to be the same place that you find your factorial button, like we did yesterday. And so that's where you're going to find this. Now, if you were to type it in your calculator, like let's say I wanted to do 8, choose 3. In your calculator, you would type the number 8, and then you would use that button, and then you would put the number 3, and then you'd hit equals, okay? Those of you with scientific calculators, same thing. You're going to find it under the same menu. You're looking for this probability menu on your calculator. Now, where is this number coming from? This is the formula. You take n, which is how many items you have total. So we're going to do n factorial divided by n minus r factorial, that's how many you have minus how many you're choosing, times the number that you're choosing, how many things that you're choosing. And there's a lot behind this formula. It has to do a lot with what we did yesterday about, the things that repeat. But that's the formula that you will need to use. Is it important to know this? Yes. Can you do it in your calculator? Yes. So that is just fine. If you ever find yourself without a calculator, that's the formula that you're going to need to use. Here we go. Okay, now a little bit of background information. A lot of these combination questions have to do with the deck of cards. And so in case you're not really familiar, you're not a super poker player, a standard deck of cards has the following attributes. 1, there's 52 cards total in the deck. We're not including jokers. These are the non-joker cards. They're all listed over here to the right-hand side, but the breakdown is basically there's 4 different kinds of cards, and we call those the suits. The spades are black, the hearts are red, there's diamonds that are red, and clubs that are black. If we look at over here, those of you that aren't familiar, these are spades, the kind of upside down heart. Obviously, those are the hearts, those are the diamonds, and these are the clubs, the ones that look sort of like a clover of some sort, okay? Within each suit, there are 3 face cards. They're called face cards because the card has the people on them. You can see their faces. That's going to be the king, the queen, and the jack. There's also going to be 1 ace. It does not, for the intents and purposes of these problems, it does not count as a number. I know in some card games we count ace as 1. In some card games you count it as 13. We're not going to count it as anything in this one. It's just going to be an ace. And then there are the number cards that go from 2 to 10. And so you can see all of that information right there. Some of that's going to be important as we move through different problems. So here's an example of a type of problem that's pretty typical when it comes to these combination problems. You're being dealt a 5-card hand from a standard deck of 52 playing cards. So the first question is, if the order in which the cards are dealt is not important, how many different hands are possible? Well, again, we talked about this not important, order not important, being the most important thing. That's what tells you that this is going to be a combination. Okay, so what we're trying to figure out is how many ways can we choose 5 cards out of a deck of 52. That would be a combination, so we would do 52, choose 5. And we'll set that up using our formula. Or you can just put it in the calculator, which is what I did, and we get 2, 5, 9, 8, 9, 6, 0. Remember, every 3 is where the commas go. So it's 2,598,960 different possible card hands. Okay, this seems like really random, but think about all the different games in Vegas and in all the different casinos, even around here. They have to decide, why are some hands worth a bigger payout than other poker hands or in other different games? It's because they've gone through and calculated exactly what's the probability of getting a straight, what's the probability of getting a straight flush. The things that are more rare end up being a higher payout if you happen to win. When there are 2.5 million different possible hands and there's only 4 ways to get a royal flush, that's pretty impressive. So, that's a much better probability. Now, here's the second thing. In how many hands are all 5 cards the same color? Now, this question really ties back to that fundamental counting principle that we talked about yesterday, because we have 2 different things that we get to choose. One, we get to choose the color, and then 2, we get to choose 5 cards. Okay, now remember, we multiply those. If I have 5 different pairs of pants, 3 different t-shirts, and 2 pairs of shoes, I would multiply all those things to figure out all the different combinations. So how do I choose the color? How many different colors are there? Well, there's 2, red or black. So of the 2 colors, I need to choose one. And then once I narrow it down to only 1 color, how many cards are there for that particular color? If we had a total of 52, half are red, half are black, that means there's 26 that are 1 color. Now, it doesn't matter, according to this question, which cards. Let's say I pick red. It doesn't say what kind of red cards I have to have. I just have to have 5. So out of the 26 that I choose, that are whichever color I chose in that first part, now that I've selected the color, I need to choose 5 from within that color. Now that's kind of a tricky concept there. So let me kind of explain this to you again one more time. First thing we had to choose was the color, and there's 2, red or black. So that's where the 2 choose 1 came from. We're going to multiply that by however many ways there are to choose 5 cards out of the 26. So I have 2 different possibilities here. First, I choose red. There's 26 red cards that I then get to pick my 5 cards from. I can't pick from the black cards because then the colors wouldn't match. Or I could choose black. Well, there's still 26 black cards that I could choose from. I cannot choose from the red cards because that wouldn't be the right color. They wouldn't all match. So now we get out our calculators and we work all of this out. How many ways are there to choose one thing out of 2 items? There's only going to be 2. The second one, I'm going to have to get the calculator out and do the formula. And I get 65,780. I'm going to multiply that by 2. And so the final answer of all the possibilities is 131,560. Okay? You'll notice the odds of that happening would be much higher. We've cut it down from over 2.5 million possibilities in the first one when I can just have any 5 cards to now I'm down to just over 100,000 possibilities. So it makes a big difference when you start putting restraints on those things.